A while back, when Bill Nye and Ken Ham had their debate at the Creationist Museum, Bill Nye was asked by an audience member, besides the geologic column, what is the evidence that the Earth is more than 6,000 years old? And he sort of stumbled over his answer and essentially said that the geologic column was overwhelming evidence that the Earth is old. And that's true, but there's a problem because that evidence is not directly accessible to anyone but scientists. And so for ordinary people, you still have to take scientists' word for it that the geologic column shows that the Earth is old. And what this video is about is trying to convince you that the Earth is old using evidence that's directly available to you. You don't have to take anyone's word for it. And we're going to use Google Earth. So I encourage you actually to do this experiment yourself. Just hop on Google Earth and follow along. So we're going to take a look here in California, and in particular in the San Francisco Bay Area, and start out by convincing yourself that what Google Earth is showing you is actually true by zooming in on wherever you happen to be. Go take a look at your home, and then look outside and see if what Google Earth is showing you is actually an image of reality. So I don't know where you live. I'm just going to take a look at San Francisco International Airport, where a lot of people have flown through, and so that's one place that you can sort of establish the ground truth that Google Earth is actually showing you reality. And this is actually where we're going to start our journey, because right next to San Francisco Airport there's this very interesting feature. There's these two lakes here. There's one of them, and here's another one, and those are very interesting lakes because they're long and skinny, and they're in an almost exactly straight line, which is kind of unusual. You can kind of look around this area and you'll find a lot of lakes, like here's one, and there's one over here, one up here, but none of them are long and skinny like these two. And if you follow the line of these two lakes up to the north, you'll find another long skinny body of water. This one's not a lake, this one happens to be a bay. This is open to the ocean up here, so this is salt water, but still a long skinny body of water in the same line as these two lakes down here. Now what happens if we follow this line down in the other direction? If you kind of use your imagination, you can sort of see that this line extends down to the south, and in particular down here in the middle of the desert you'll find some more of these linear features. These happen not to be filled with water, but you can see here there are these features here that are, again, in an almost exactly straight line, and they go on for hundreds of miles. This line, if you follow this line back up to the north, you'll see it cuts right back through the same line that these lakes make. So what you're looking at here is the famous San Andreas Fault. And it's the boundary between two continental plates, the North American plate over here on the right, and the Pacific plate on the left. And the Pacific plate and the North American plate rub up against each other and move, and that's what causes all the earthquakes that we have here in California. So keep that in the back of your mind as we go through the rest of this. And now we're going to go over here into the middle of the Pacific plate and take a look at Hawaii. Hawaii is a very interesting place because it's this little group of islands here, and down here in the lower right hand corner in the southeast is the Big Island of Hawaii, and on the southeast corner of the Big Island of Hawaii is the world's most continuously active volcano. It's called Kilauea, and it's right here, and you can actually see the steam coming out of it. Under the ground here there is this very large plume of magma, lava, and right now it happens, in historical times, this crater here was actually full of lava. You'll find written accounts written by Mark Twain when he visited Hawaii in the 1800s of visiting this, it's called a volcanic caldera, and seeing it full of molten lava. But nowadays, the lava has actually moved a little further downhill and is now coming out the side of the hill here through a volcanic vent called Pu'u'o'o. It's actually over here. And the lava flows mostly underground and eventually dumps out into the ocean along the coastline here. And if we zoom in, we'll see some more interesting features. If I can find what happened to my road here. Up there it is. Down here, if we zoom into the coastline, we'll see this road. This road is called Chain of Craters Road. And if we follow it over to this area, you'll see that the road ends. If you get to this place, they don't let you go any further. You have to turn around, and here are all these cars parked here at the end of the road. The road itself physically goes on, but they don't let you drive any further, and the reason for that is that if you go in this direction here, the road has been covered up by lava. This very large lava flow. And we know that this is a historic flow. This flow happened, well, different parts of it have happened at different times, but all within the last 20 or 30 years. And we know that, you don't have to take my word for it again, we can tell that the lava is younger than the road because the lava's on top. So the road has to have been built before the lava poured out on top of it. And there's another interesting thing that you can tell now, because we know that this lava over here is young, new, and this lava, this is all lava, this whole side of the island was built up by lava coming out of this volcano. So this lava must be older than this lava because this lava is underneath the road. The road has been built up on top of it. And so we can observe that young lava is darker than the older lava, which kind of makes sense, because as the lava cools and gets weathered and eroded, it basically turns into dirt, which is brown. The young lava is black, so it just weathers and fades, kind of like paint on the side of your house. And so you can see here that on this side of the island there's a lot of young material, and these again are all historic flows that have taken place in historic times. And if you actually go there, you'll see signs saying this lava flow happened in 1970 and that one happened in 1980. They've all been very carefully recorded. This is not the only volcano on the Big Island. There are actually 5 of them. The second one is over here. This one is called Mauna Loa, and it's also an active volcano. It's not actively erupting right now, but you can tell that it's actually active because you can see steam coming out of it. And this one also has a volcanic caldera. Its boundaries are right here. And in the bottom you can see, again, it's not molten lava, but it's very young material because it's very dark. And it's actually kind of interesting to, if I can figure out how to do this, change our perspective here so that we can look inside this caldera obliquely. I need to figure out a faster way to do this. So here you can really see the walls of the caldera, and right here there's a little tiny mini volcano right in the center. And that's how you can tell that this is really a volcano, even though there isn't lava coming out of it right now. Mauna Loa is really a huge volcano, and when it erupts, and it's only a matter of time before it erupts again, it's very likely to destroy the city of Hilo, which is over here on this side of the island. So again, you see lots of evidence of recent volcanic flows here, all dark material, not very old. If we go further to the north, we get to Mauna Loa, which is a dormant volcano, And here there's no dark material, or very little of it. So that's how you can tell that this volcano hasn't erupted in a much longer period of time since this volcano erupted. There's another one over here. This one is called Hualalai. And this one has a fairly recent eruption over here. And then the last volcano is up here in the northwest corner of the island. I don't remember offhand what this one is called, but if you look very closely here, you can still see the remnants of the caldera. And this volcano you can tell is older because it's all been overgrown with plants, so it's not even brown anymore. It's all green. The reason that this area over here is still brown is because the trade winds blow in from the east and dump all their water on this side of the island. This is a ridge. So by the time the air gets to this side, it's been depleted of all its water. And so this is basically just a desert. But again, the material here, no dark black material, so no recent eruptions. What happens if we keep going in the same direction? The next island we get to is the island of Maui. And you see a very similar pattern here. On top of Maui, there is a volcanic caldera. This one's called Haleakala. And here again in the center, just like we saw on Mauna Loa, little volcanic cinder cones. But again, the material here is not very dark, so it's been a while since this volcano has erupted. There is one fairly recent eruption over here. This is a couple of 100 years old. This particular lava flow here happened again in historic times, the 1700s as best they can tell, and it formed this bay here called La Perouse Bay. And there's another road on top of it. Right here, you can actually drive on this road, go down to the end and take a look at this beautiful new bay that was formed by this lava flow. But that's it. All the young material that there is in this tiny little corner of the island down here. The rest of it is all brown or overgrown green. So not a lot of recent volcanic activity. Maui is actually two islands that are joined by this little lowland saddle. This is the second island over here. And there's no young material on it at all. And you can see here's the old caldera, and it's almost completely eroded away. You can barely see it anymore. And the same trend continues as you keep going in this direction. Here's the island of Molokai, and you can see the old volcanic caldera here. There's a larger one here. But again, they're kind of hard to pick out because they're almost completely eroded away. Keep going and we get to the island of Oahu, where it's very hard to find evidence that this was once a volcanic island, but it was. And down here, again in the southeast corner, is something that is recognizably a volcano. This is Diamond Head. That's very famous because up here is Waikiki Beach, and so if you ever go to the island of Oahu and stay in one of the famous hotels on Waikiki Beach, you will see Diamond Head off in the distance. It's a very beautiful sight, but that's all there is on Oahu. Keep going to Kauai, which is the last major island in the chain, and here it's a real challenge to find the old volcano. It happens to be right here. It's called Waialeale. It's interesting because it's the wettest spot on Earth. But Kauai is, again, almost completely eroded away. You can see all these erosion channels. There's no lava on Kauai at all. And finally, there's the island of Niihau, which is completely eroded away. There's hardly any topography on it at all. But again, we can see little bits of remaining evidence that there used to be volcanoes here. There's this tiny little crescent-shaped island here. And what this is the top of a volcanic cinder cone that has been almost completely eroded away and has faded back into the ocean. Now the interesting thing is this is actually not the end of the Hawaiian island chain. It goes on and basically in the same general direction, for about 3,000 miles. But we don't find any major islands anymore. What we find is little rocks like this. This is called Necker Island. And it's just a rock out in the middle of the ocean. And we find a lot of underground seamounts. Underwater. Sorry, that was not Necker Island. This is Necker Island over here. But again, it's just a tiny little spot in the middle of the ocean. So a lot of underwater islands, underwater seamounts, one over here, and what are called coral atolls, like this one here. This is a coral reef, and they always grow in these circular patterns, and the reason for that is that they started out growing around the outside of an island that used to be here and has completely eroded away. And if you are following along on Google Earth yourself, you can just explore this area on your own. You'll find lots and lots of these beautiful coral islands that are in various stages of formation. Like here is Midway Island, which is still recognizably an island, but no evidence of volcanic activity. But there's all this coral growing around it, making these beautiful saltwater lagoons. And again, this chain goes all the way up to here. Let's see if I can find you a nice coral atoll to show you. Nope, not this time. Now, how did this chain of islands form? Well, all these islands were built by this same volcano down here in the lower right-hand corner of Hawaii, because this volcano is caused by this very large pool of magma that's underneath the crust of the Earth. It's called a hotspot, and the Pacific plate moves in this direction. And the way we can tell that is because the line of the Hawaiian Islands is almost exactly parallel to this line over here, which is the line of the San Andreas Fault. So this entire plate is moving in this direction, and it's causing earthquakes over here, and it's basically dragging the plate over this hotspot, where the hotspot builds up islands, and then the plate carries them away, almost like a conveyor belt. And another bit of evidence that this is what's going on is over here, under the water, there's a new island being formed. It's called Loihi, and it's on track to break the surface of the water in about 10,000 years. Now, how does this show that the Earth is more than 6,000 years old? Well, we can do a little calculation to figure out how fast this plate would have to be moving in order to build up this 3,000 mile long chain of islands in 6,000 years. If the Earth were only 6,000 years old, then this would all have to have been built up in 6,000 years. Never mind that there's actually more of it up here, but it makes this funny bend. So we'll ignore that for just a moment and just do a rough back of the envelope calculation of how fast this plate would have to be moving in order to build this in 6,000 years. So 3,000 miles in 6,000 years is about half a mile a year. And if Hawaii were moving at half a mile a year, you'd notice. So you could go there with a GPS unit and find a spot on Hawaii and have your GPS tell you where that was. Go back a year later and see if it's moved half a mile. And if you actually do that experiment, I promise you'll find that Hawaii is not moving that fast. The actual rate of motion here is about 10 centimeters a year. And at that rate, it takes about 600 million years to build just this chain of islands, which is about 15% of the actual age of the Earth.